In this video, we're going to use a second derivative test to identify all the local max, mins and saddle points of a surface. So given this surface, our job is to identify all the max, min, or it could be a saddle point. It could be a saddle point. So just a reminder, we've done all this before, so if you don't understand it, backtrack. Just a reminder, if you're truly at a top of a hill, if you slice it in the x direction, so this, you've got a vertical sheet of paper, then if you're truly at the max, then the gradient right here would be 0. And then if you slice it in the y direction, so if you slice it in the y direction, this vertical sheet of paper will intersect a surface somewhere around here. And then if you're truly at the max, then Fy will equal 0 because the gradient will be 0. And if you're truly at a min, then if you slice it here, then the gradient will be 0 if you're truly at the min. Now if you slice it in the y direction, your vertical sheet of paper, if you're truly at the bottom, then the gradient will be 0. So this is a good indication to identify if you're at the max or if you're at a min. And remember from single calculus, differentiate it once, differentiate it twice. This tells you the concavity. So if you differentiate this twice with respect to x, 1, 2, this thing here, in a way, it tells you the concavity along the x direction. Okay, so just like over here, this tells you the concavity. This also tells you the concavity. Just because this equals 0 and this equals 0, it doesn't mean that it must be a max or it must be a min. It could be a saddle point. It could be a saddle point because let's just imagine in the direction of the horse's head, it's the x, and in the direction of the right hand side, this is y. Let's just imagine this as this. So you can see that the concavity here will be 0. So here fx equals 0, and if you look at fy, if you look at fy, it's also equals to 0. Just because these two are equal to 0 doesn't always mean it must be a max. It must be a max or it must be a min. It could be a saddle point. This is why we use a second derivative test. So this tells us this gives us an indication. If you look at the the first step is to identify all the critical points. So the critical points occurs at these when x and y here equals 0. Once you've got these points, then work out, look at the concavity. So the concavity is you differentiating it twice. If you're truly at the top, then the concavity will always be 0. But then this is not sufficient. You have to do an additional piece of test. Look at this quantity. If this quantity is bigger than 0, then you can definitely conclude that you're at a max. So there should be this and. So there must be an important and in here. You must satisfy these two conditions, then you can conclude. This alone is not sufficient. Okay, and also if you're at a local min, then look at the concavity. If you're really truly at the bottom of the hill, then the concavity will always be concaving up. So, but this is not sufficient. You've got to perform an additional piece of information. Then you can conclude, combining these two together, then you can conclude that you're at the bottom of the hill. And saddle point occurs when this quantity is less than 0 and is inconclusive if it's dead on 0. Okay, so in the next video we are going to look at this surface. We are going to look at this surface in the next video. Okay.